Can we start with number 2 today, actually? Number 2. I like number 2's example. It's easier for me to explain with number 2 what we're doing. All right. A bunch of people just asked me questions on Friday's homework, and the bottom line for me is, hey, the more people we get in the sample, the better our results are. All right, or the closer, more confident we are in our results. So here's what we're going to do today. We're going to do some type of experiment. And I want to know, is our result unusual, or does it fit right in with everything else? All right, is our result a little unusual, a little extreme, an outlier, or is it right with the rest of them? So take a look at Jack here on number 2. And I'm going to forewarn everybody, these problems get a little lengthy. Not as far as the work we need, but as far as the reading goes. So get used to that today and tomorrow. They're going to get a little bit more wordy. So he's spinning a spinner, right? He's spinning a spinner. So he did it 100 times. Why? I don't know. Don't ask. It's just part of the problem. He's spinning it 100 times, and he gets 31 fives come up. 31 fives. And he wants to know, is that unusual or not? So here's how we're going to test if 31 fives is unusual or not. First vocabulary term I got to give out today. Observed proportion. Observed proportion. This is what happened in the experiment. Okay. What actually happened? What actually happened? Well, he got 31 out of 100 fives, right? So our observed proportion is 31 out of 100, which as a decimal, and I'll show you why I like it as a decimal, would be 31 out of 100 point 31. And that's what these numbers at the dot plot represent. What decimal out of 100 did you get fives? All right, so we got about 31% fives came up. Now, is that unusual? Is it a sucky spinner? Or is it a fair spinner that I got 31 fives? Well, we're about to test that out, if that's unusual or not. So here's what happened. And it's easier for me to use you guys as the experiment than just trying to read it through. So what he did is he repeated 300 times. He repeated this 300 times. So basically, here's what happened. Maddie, take this spinner, spin it 100 times. Let me know how many fives you get out.
I got 31 fives.
All right, well... All right, let's say 15 fives. They got 15 fives on the spinner. So what's 15 out of 100? As a decimal, 0.15. So that's what that little dot right there means. And then I go to Emily. You do it 100 times. Let me know how many fives you got. And she responds, I got 20 fives. What's her proportion now? 20 out of 100 or 0.2. So there's Emily's dot. And I keep doing this. And I end up going to 300 people to spin this spinner 100 times. Pretty good sample, right? Pretty good sample. And this is what I ended up with, this dot plot. Every time they spun 100 times, they reported back to me how many fives they got. I divided it by 100, and I kept plotting where the decimals were. So I want to know, is Jack's 31 unusual or not? Now, if you look at the dot plot, everyone see where 0.31 is. Where is it? It's not even close to the rest of our spins, right? All right, but I don't want to say that. I want to mathematically prove it. And the way we do it is 0.31 in our confidence interval or not? Because if it's outside our confidence interval, that's unlikely. It's unusual. All right, but if it's inside our confidence interval, the spinner was probably fair. So I need you guys that were here on Friday. Can you help me find the confidence interval for this experiment now, this simulation? What's the first thing I need to find before I find a confidence interval? I got it.
Oh, we do?
Margin of error.
Margin of error. And how do I find margin of error? Plus or minus 2 times standard deviation, which in this case they give me right there. It's calculated for me, 0.041. And you guys have your calculators. Let's roll. Got to find where I put my answer key. There it is. Here we go. Let's go. we're getting plus or minus 0.082. All right. I asked for confidence interval though. I need to see where 0.31 is in my confidence interval. So how do you use your margin of error now to find the confidence interval? Mean, here, mean, and then plus or minus that margin of error, which means I'm going to add and subtract the margin of error from my mean. And just a heads up, I know I kind of went over the rest of the directions here. The confidence interval has to be to the nearest hundredth. So watch out, nearest hundredth. Okay. So what do I have? 0.199. I'm getting that from the dot plot, everyone. 0.199 plus or minus 0.082. So make sure you add and subtract. So your confidence interval is going to be, what do we have here? 0.12 to 0.28. So is Jack's result likely? No, it's not. So maybe we could say the spinner wasn't a fair spinner. Maybe it was weighted a certain way. All right, but that's not that's an unlikely result. It didn't, let me put it this way. It didn't happen by random chance. Okay, didn't happen by there was something that it didn't happen by random chance, because this is where it should have fell in between. So I'm just going to leave. I thought the easiest way for you guys to write out our final response is just to put some blanks in here. So the confidence interval based on this simulation was what? 0.12 to 0.28. So the observed proportion of fives, which was what?
0.31.
So the observed proportion of fives of 0.31 is not within our what? The confidence interval of this simulation. Right. So again, what this is telling me is that's unlikely. It's for some reason other than just by chance that we got 0.31. So that's what our goal today and tomorrow is. We're going to do some type of experiment, come up with a number and say, all right, is that a likely result or not? All right, based on our confidence interval. Questions? All right, hey, senior class. There you go, right up our alley, except for university. They're going on a senior trip. Oh, that's cute. So the senior class president conducted a survey of 100 seniors, and 65 said they wanted to go on the senior trip. Oh boy, maybe we should worry, huh? Because it said 75% of the senior class was interested. So should we worry or not here? That only 65 said it. Well, 65s are, what's our observed proportion here? 65 out of how many people surveyed? 100 in this case. So our observed proportion is 0.65. Because right now you're the senior class president. You're like, oh boy, we're in trouble. All right, I said 75%, only 65% I sampled. But let's see if that's actually true or not, or unusual. What do you think of predictions just based on the dot plot? See where 0.65 is? What do you think? It's going to be outside or inside? Just where 0.6 is on the 0.65 is on the dot plot. Where do you think it's going to be? Might be an unusual occurrence, so maybe the senior president shouldn't worry about. But let's find out mathematically. All right, mathematically, let's do this. Go ahead. Margin of error. Plus or minus 2 times. Which one do I use there? 0.75, 0.043? Oh boy, I got multiple responses.
0.043.
0.043.
Oh,
And let's see, what are we getting there? 0.086. All right. Remember, confidence intervals are to the nearest hundredth here in these problems. So my mean was what, 0.75 plus or minus 0.086. Bottom end, you get 0.66, nearest hundredth. Top end, what do we got? 0.84. All right, so mathematically, what happened there? 0.65, inside or outside? Outside. So again, what that means, if it's outside, that's unusual. That's unlikely that it's going to keep happening. All right, that 65% are just going to want to go on the senior trip. All right, so that just by him doing 65, he probably shouldn't take that to the bank. All right. So the confidence interval, we could fill this out now, 0.66 to 0.84. So the sample of 0.65 is not within our confidence interval. Bless you.
thank you.
Anything else? I'm going to go back to one now. It was just easier for me to describe what we're doing here today in testing using those first two examples than this one. All right, so we got somebody running for good old student council president. Perfect. Got to get over 50% of the vote. Yep, all right, we got that. So we did a random sample of 15 students from the high school. 26 said they'd vote for candidate A. What's the 26 out of 50 now? Observed proportion. So 26 out of 50. Anybody got a little decimal action there? 26 out of 50. Oh, so candidate A is like, hey, I'm in the money here. Nice. I'm going to win. Well, that's easy, boss. All right, easy. Let's see, because if that's an unlikely result, you got some tougher times coming. But if that's likely, then you're probably good to go here with the election. So let's see if 0.52, if we could see on the dot plot, any predictions? Likely or unlikely, as we, how many more? We did 100 more of these simulations. So probably likely, yeah, but let's do it mathematically, right? I'm glad you guys are picking this up just looking at the dot plot because that's going to be key tomorrow. All right, let's see if it's actually likely. Margin of error, plus or minus 2 times 0.069. Plus or minus 0.138. And then my confidence interval, 0.497 plus or minus 0.138. Again, I'm just getting the mean right off the table. Nearest hundredth, 0.36 to what I got, 6.4. Making sure I rounded that correctly. And then, so where did our observed proportion fall? Right in there, huh? So he or she should feel pretty good about themselves. All right, because that's a likely response right there, 26 out of 50. And I apologize here about the way I set this up here. Yeah, I know. I dropped the ball on this one. All on me. Leaving this in. What am I doing? It's embarrassing. All right, so the confidence interval, 0.36 to 0.64. There should be another blank in here. So the observed proportion from the sample survey of, there should be a little line in there of, what was my observed? 0.52. Now what am I going to put is within the confidence interval. We've been putting not within, but we finally got one. So within the confidence interval. If you couldn't tell, I got this off like an interactive site and decided to keep the little drop-down menu right there.
That's strong.
No, not at all. Adds some unprofessionalism. Questions? Okay, can I see you do 2 on your own then? 4 and 5. Let me see you do 4 and 5. You can work with the people in your group. Yep, 4 and 5. So tell me about Connor. Did he have a fair coin or not when he got 45 out of 100 tails? And if anybody's doing the quick math there, that's 30,000 flips that's going to end up happening here. So I think that's a pretty good sample size. He's doing 100 flips 300 times. Because you can go in either the mean can go to the left or to the right.
So how do you find out if it's subtracted?
It's both.
You always just.
It's always both.
Wait, but like.
The margin of error is how much you're off from the mean, the actual mean.
Oh, I'm.
So you could be off 2 points in either direction.
I'm talking about like the confidence. Mean plus and minus.
Correct. So you take the mean, subtract the margin of error, that gives you the low end. Mean plus the margin of error gives you the high end.
Oh, okay.
Because with that, the confidence interval is where is the population mean, which we're never going to find. Like if I try to find how many hours of sleep the town of Del Mar gets, I'm never going to find an actual single number. I can get a range of numbers. That's what the confidence interval is. That's why I have to subtract and add. You're never going to get an actual value because it's just the the population's too big. Yep.
So for this one, like, where does this come from? Is it from your company? Oh, the standard deviation.
Correct.
So you just do.
It's plus or minus 2 times the standard deviation. That's the formula for margin of error.
Yeah, on number 4.
Yeah.
Correct. And usually the mean is given to you as well.
There's a.
I'm not sure if it does.
Which one was that? I got 0.3 times, but then I would have to see. I have to see myself. What I got to go to 0.5.
There's no honey?
This is my hundred.
No, that's just a.
But I think you did the rest of it right. Did I get the same at some point? Oh, my observation is for you.
No, I think you're the observation. Is the observation from 30 or 22?
0.25.
The second?
Yeah. Because you don't.
Really just looking at it. We're outside this one, just like making sure. That's how I bought right.
And that's like.
She's like bleached. Like I could get.
I don't like.
I don't know what to do with it. Like that, I have to like scrub that.
Well, that's what
It looks like they.
like 4 or 5.
Oh,
I never did the plus. Leaving at 4.
but you should round it. You might get 0.4 or 0.5.
Yeah, that's what that is.
0.4.
Yeah, you should be.
So on that first one here, Connor probably had a fair coin. Right, 45 is not out of the ordinary to get after we did 30,000 flips. I don't think 45 tails out of 100 is unusual at all. All good on that one. 0.4 to 0.6 was our nearest hundredth, our confidence interval. And then the rugby team. Now you get a little scared because you went out and surveyed, about 100 randos, and only 25% of them said, yeah, we can do the rugby team, and you need 30%. So you get a little worried, but is 25% really that unlikely? No, it's fine. Fell within our confidence interval. Okay. Questions? Get ready to get a little interactive tomorrow and actually stand up out of your seats and move. Yeah, no. All right, I am not going to be wasting the last 15 minutes here. So what you're going to get right now is the review. Because it's not at the end of your packet. Don't know if you didn't notice that. I wanted to do review separate, so at least you could go through your packet while you're trying to answer these.
Oh
so
my
you
God.
could start.
Yes.
So you could start on the review right now with the people in your group. Call me over if you have questions. You guys know where the answer key is under homework answers. Let's get reviewing right now for Thursday.
Elizabeth! Wait for 6 minutes. I would never wait.
Nope. All right, so let's get going on the review. Call me over if you get stuck. You know where to check your answers.